of the place where you stored the roots and the weights for a certain number of points, a certain degree. Right. We also need the degree, because otherwise we can't parse roots and weights. It's just we don't know how many. So we want you to be able to compute this thing, the roots, the weights, for a specific value of n, and then to just give that to the function. You just want the function to know it after, to not recompute it every time, but at the same time you don't want to need, you shouldn't need a messy initialization of the function. So I think what we will do, hopefully that will work, is that actually find root integrate. Okay, so that's signature. Alright, from A to B, integer n, a function, and then we pass a pointer to a quad info. Right. So the first thing we actually need to give it a name, info. First thing, if info is not a valid address. Okay, so I don't know if I mentioned this before, so I'll say it. When you give the address, it's a number, but there's a one specific number that the computer or the C, the programming language, understands to mean not to point at a specific location in memory, but it's like a code that says invalid memory. So you can think of it as being just 0. Okay, so 0, the address 0 doesn't point to a place in memory. It just tells you that you don't have a valid address. So before allocating a quad info, if you just declare a quad info, I think you don't have a valid address. So the idea is that okay, that's one possibility. The other possibility is that info n is not equal to, actually we have to treat those differently. Okay. Then afterwards, everybody does it. So the first time you just give what we call it a null pointer, okay, an invalid address, and then the function is going to go in the memory, allocate a place for your quad info to live. It's going to compute the roots, compute the Legendre polynomials, compute the roots, compute the weights, and then you're all set. Okay. And if you've already computed the roots and computed the weights, but now you want a different value of n, right? What we'll do is we'll just compute everything again. Throw away the old stuff and compute everything again. You might think that this is wasteful because in certain circumstances you might think you have two values of n equals to 10 and n equals to 100, and you're just alternating between these two, and then you keep messing the thing up. You keep recomputing every time because you don't have enough memory. But actually, if you see that this is a problem, the only thing you need to do is to keep track of the quad info outside of this function and just call the function with the right quad info, or the one that matches the value of n if you want. An alternative approach would be to keep somewhere in memory to just remember all, like a certain amount of quad infos you've already computed for different values of n. I think this is relatively simple, and yet it does the right thing. Okay, so you have like two special cases. Either info has not been set to anything, or it's not set to the right thing. In both cases, you have to fix info, and then, no matter if info used to be bad or if it started perfect, then you have to use it to do the whole thing. So, okay. Okay, so at this point, we can talk about the roots, the weights, and the value of n. Then the code I'm going to write is basically going to be the same in both of these branches, so we might want to reorganize afterwards, but for now let's just do it. So info arrow n equals n, and this is going to be a little dumb, okay, but that's fine. It's completely fine. It's going to leak some memory and so on, but that's okay. Just to get the thing working. So roots. Right. That's all. And then see. Problem, you might want to condense these things because it's repetitive. Actually, in the case of info pointing to n is uninitialized, but in this case, info pointing to n is just a wrong value. So you can't say, for example, if not info, just allocate info, and then go and do this whole thing for both these cases. Now, how do you keep track? But